hold on. Okay, so the first one is some of them are claiming that they want to change the default PMP into the letter graded, and they have trouble doing so. It's like this is not something I can handle, and I don't know, like it might be like I also tried it myself to like how do I change it, but like I have like some trouble on like swapping to letter grade as well. So I guess there's some problem with CodeCentral. If you are from LNS, I would recommend you to arrange a remote meeting, a virtual meeting with a college advisor. I think it happens on the official website. So that's one of the logistic issues. And some other students asked me the range for this quiz, or like maybe the other problem. Like one of the students asked me like for the last quiz, I actually accidentally include some of the information like there so that quiz is on Thursday. I'm supposed to testing the information inclusive on Monday, but not on Wednesday lecture. I actually test you on some of the materials on Wednesday. So I guess for that problem, so that's like problem 2 in quiz 11. I will allow you to quiz correction. And remember the guideline for quiz correction is that if you mention like why you're doing wrong, and the correct solution, and in general, how do you solve this type of problem? So that the third step is the crucial step. And the first two is something I assume that you should always know that once you really know this question. But the third one is the thing I'm looking for. And if you do like all these 3 steps very good, you might get like more than 50%. And if you did really, really good, you might get like 100% back instead. Like 100% means like 100% of the point you lose and you get it back. So that's it. And I just noticed from today's quiz, I also actually include some of the information on like Monday's material. So I guess just like if you are doing the quiz, just like feel free to look at the discussion worksheet. It has like similar problem to like discussion worksheet, like specifically section 2 on like Monday's lecture. And like I mean like I guess I will also like provide a quiz correction on quiz 12, like depending, or actually I mean I'll just wait until like some of the students ask me if there's a quiz correction. If none of you ask me if a quiz correction, I will not do that. But like if one of you ask me a quiz correction, I'll probably just like do the quiz correction. But whatever, like maybe like all you guys are doing pretty well on quiz 12 and all you guys are mastering the materials, so don't need the quiz correction. But yeah, most likely there will be a quiz correction on 12. Like I even mentioned that before you're taking the quiz. So I guess like it kind of relieves the stress of taking the quiz. Yeah, so that's the third thing. The fourth thing is the homework are due today at 11:59. So they're up on B course right now. So that might be if you finish that already, probably just like submit it right away. Yeah, and the fifth thing is that your tentative scores of class is up on your B course. I also make an announcement yesterday that this score is out of 69. So that's everything other than some of the discussion and lecture participation and the final exam. So it is out of 69, and like you guys are actually doing better than the class average. So I'm happy with that. But like I noticed that some of like our participation score in discussion and the participation score in lecture is actually lower than other sections. So guys, you guys just have to like participate more on the lecture. Like like I gave you a very good score on the discussion participation, but like still some of you didn't show up, so I can't give you the score. But on the lecture, like still like a lot of you didn't, not a lot of you, but like there's more than other sections of you didn't show up. So I guess like if you want to get better score on that section, maybe like participate on the lecture and actually show up and do the polls correctly. Yeah. So there will be a quiz on today's tutorial. Let me see, is there anything I want to include before I jump into today's discussion? Yeah, maybe not. Yeah, so I think that's everything I want to mention. Yeah, and as for like the letter grades corresponding to the score, like you can, there's two ways to do that. First, using the knowledge on normal distribution. And because we are providing the mu and sigma, so you should be able to calculate the percentile. And like you can compare your percentile with Berkeley time. Like although BerkeleyTime.com provides you like the history of this distribution. So that's the rough estimation on your letter grade. So usually if you get 1 as the above mean, that is a A. And if you get mean, that is a B. If you are 1 standard deviation below mean, that's a C or less. Yeah, so that's usually how you calculate. But like, it also depends on how professor evaluating our class. Like the fact is that the 2 p.m. class is significantly better than the 1 p.m. class. Like our mean is like always 10 points higher than the for like midterm 1, midterm 2 are 10 points higher than the 1 p.m. class. So I guess if I were the professor, I would give better grade on 2 p.m. class than 1 p.m. class. So all of you are from 2 p.m. class. So you guys shouldn't be too worried about that. And one thing I want to mention is that for today's quiz, and also like for the quiz, we are taking the top 10 for consideration. So that means like for today's quiz and tomorrow's quiz, or actually the quiz before this week, like they are just like if you take this quiz, it just can make you better. And actually, I would strongly recommend you to take this quiz because the quiz I made for this week and next week will be relatively easy to get scores, get the points. So like if you can, if you actually like do a little bit preparation on the simplest problem and do the homework correctly, you should be able to get perfect scores on my. Or actually, yeah, if you just do like a lot of some preparation before the quiz, you should be able to get pretty good scores on the quiz. So I would strongly recommend you to do the quiz for today's and next week's. Yeah. Is there any logistic problem before I move into discussion? Yeah, I guess it's no. So let's move to discussion. So for problem 1, or for this discussion, we'll be including 2 parts. The first part is hypothesis testing 1, and the second part is hypothesis testing 2. And we will not do too much of the problem. Instead, I want to like focus on each problem and make the quality of each problem good. So I will provide a lot of like intuition and make sure that the solution process of each problem make perfect sense for you. So that if you know this, like if everything makes sense, like if I gave you any problem, you should be able to solve. So let's first start with one measurement problem. So remember, like in hypothesis testing, we're always having a null hypothesis. And the null hypothesis is something that we assume it to be true. Assume to be true. And we want to do measurements. And want to do measurements to say like if our measurements are saying that we can reject or we can reject our null hypothesis. If we can reject the null hypothesis, we will go to the alternative hypothesis, which are usually the contrary to the null hypothesis. But if we can't reject our null hypothesis, we'll stick with null hypothesis. Our quiz today will include hypothesis testing. Actually, that's the majority part of today's quiz. Because I have tested enough maximum likelihood last time. Yeah, just one of the students asked me a question just now. So if we do a measurement and we are saying our conclusion would be if we reject or don't reject our null hypothesis. And there are two ways for us to get, or actually before we do that, there are two types of tests. One is one-sided, the other is two-sided. So one-sided is basically saying that our null hypothesis is always like mu equal to a number. So for example, mu equal to 120. One-sided will be either mu is greater than 120. So the alternative hypothesis is mu is greater than 20 or mu is less than 120. And two-sided tests are when mu is not equal to 120. So what does it mean? It means, for example, if we're measuring a patient's blood pressure, and we're claiming that the patient's blood pressure, the normal person, is about 120. So our hypothesis testing can be one-sided, and we can claim that if we are in a hospital, we're saying that those patients might have high blood pressure, and our alternative hypothesis can be the actual like blood pressure for this patient are higher than 120. So in this case, mu is greater than 120 are our alternative hypothesis. But in another situation, say we're talking about some of random people, and those people are not from like the I don't know, the heart disease department. They're from like other departments. For example, the diarrhea problem, or I don't know the word, but like those people can have low blood pressure or can have high blood pressure. We don't know it. We just want to test if those kind of person are normal or not. So our null hypothesis will be abnormal. The abnormal can be high blood pressure or low blood pressure. So we go to the two-sided test. So that means mu is not equal to 120. And then we move to how do we actually calculate the result. There are two ways you can draw conclusion. One is calculate the p-value, and one is find the rejection zone. So calculating the p-value is literally means finding. So that means finding the measurement z-score. Like it's related to the measurement z-score, and we want to say like how is it compared to alpha. Alpha is our significant level. So that's p-value. And finding the rejection zone is we are looking at alpha, and then we want to find the boundary of null hypothesis still holds. And then we want to say like if our measurement line in the boundary or out of the boundary. If that's out of boundary, that is in the rejection zone. So a visualization of these two is like for p-value, we're finding that so we're giving that alpha the critical value. So alpha maybe like stand for this region, and we're finding that if p-value is less than alpha, and for finding the rejection, so maybe like I don't know, like for p-value is more like a algebraic thing, but finding the rejection zone is like we're finding the boundary. So that's the boundary corresponding to alpha. And we want to say that if our measurement lies in this rejection zone, so the rejection zone will be here. So maybe like maybe an example would be great for us to understand the abstract concept that I just mentioned. So maybe we can look at problem 1, and I will give you 3 minutes to read problem 1, and you can like reply to me if you finish the problem, or at least finish reading the problem. Discussion worksheet should be on B course. If you can't find it, I can send it to your email. Yes, number 24. Let me see how do I send it. Yeah, and also like if you're too lazy to calculate your score, you can send me an email on your letter grade, so I can like calculate it like my rough approximation to you. So you can also like take mine as a reference. Download. And also one thing I want to mention as for like letter grade or pass no pass, is that like usually like because like given this situation, more people than usual will take it as personal class, and that means like more people are not like paying or like not work as hard as before. So if you work as hard as before, that means you definitely do better in terms of grading. So that's just one interesting observation. Yeah, and also definitely reply to me if you are finishing problem one. There's only a few people reply to me. Okay. So maybe let's look at problem one together. So problem one says X be a measurement of patient blood pressure. So that's one measurement hypothesis testing, which follows the normal distribution, right? So we can use this score. And we are giving the statistic that standard deviation is 5 and mu is 120. And we are explicitly giving that our null hypothesis, I guess the screen is frozen. Yeah, we're giving explicitly the null hypothesis is when mu is equal to 120, and the alternative hypothesis mu is greater than 120. So what does that mean? That means the question is saying that we want to check if the patient are having blood pressure or not. If we can reject our null hypothesis, that means the patient are actually normal. Their blood pressure are normal. If we actually reject our hypothesis, or null hypothesis, so we go to our alternative hypothesis, meaning that our patient has blood pressure significantly higher than the normal. And why I mentioned significant? Because we are giving an alpha equal to 0.05, and that's our significance level. So our single measurement here is 135 for the patient blood pressure. So part A, is this a one-sided test? Yes, it is a one-sided test because we're just looking at if the patient has high blood pressure instead of high blood pressure and low blood pressure. So this is only a one-sided test. And for part B, calculate the p-value. And when you are calculating p-value, remember what I'm talking about. P-value is always related to the z-score. So we can calculate the z-score for this measurement first. That is x minus mu divided by sigma. In this case, 135 minus 120 divided by 5, which is 3. So the p-value is corresponded to the p of z greater than 3, which is 0.5 minus z of 3, which is 0.0013. So on the graph, the p-value means at z equal to 3, this region is 0.0013. So that's when Z score equals to 3. So that means like that's 3 level above standard deviation. And so we can draw a conclusion right now. Can we like reject or reject the null hypothesis? Yes, we can reject the null hypothesis because our p-value is strictly less than the significance level alpha. So the idea is like this is our p-value here, and we have like alpha, which is our significance level, and p-value less than alpha means we can reject the hypothesis because the p-value is like small enough. And what's the meaning for it in this problem? That means like since we're testing if the patient has high blood pressure or it is a normal person, but we find that for this specific measurement of that patient, where it's actually 3 standard deviation above the average. It's actually lying on the very right tail here. So that means it is actually he's not normal. It's actually high blood pressure. And why is that? Because we set up the significance level at alpha equal to 0.05, and even if like the patient is, the p-value of that is 0.48, we're still saying that the patient has high blood pressure. So that's one of like way of contextualizing this problem and solve this problem. The other way is part C, when we're calculating the critical value and the rejection zone. So quickly, critical value and rejection zone is basically finding the boundary, of the boundary of the worst acceptable situation. So maybe let's draw a graph first. Because in this question, I'm giving you that my confidence level is my significance level is 0.05, and that alpha corresponded to one of the value on my distribution, and the value might be here, which means that the area on the right is 0.05, and the area between just like this is a symmetric distribution. So on the right side of mu, there are like 0.5 or 50% of the data. So that means in the middle here, there's 0.45%, like 45% of data here. But since we are saying that our confidence, what's that called? Our alpha is 0.05, significance level is 0.05, and as long as our measurement for that patient is not that significant, we're fine. So as long as our value of the patient lies in the red area, we can still call that this patient is normal. It's not like significantly higher than the average normal person's blood pressure. But if the measurement of that person is greater than this boundary here, that means the person actually has higher blood pressure because it is greater than our significance level. It's greater than our like worst situation for a person that to be considered as normal. So for this thinking, we are actually calculating the specific boundary, so which is this line here. And how do we calculate it? Because we know that this red region is 0.45, and that corresponded to the Z score 0.45. So essentially, if we are talking, so let's say that this is mu equal to 120, and we say that the boundary here is the value of k. So essentially, we are finding that k minus 120, so like the Z score of the z-score of k minus 100, the z-score of this k value here is 0.45. So remember, like k minus 100 over 5 is like standardize the curve, which means that if we're having a k here, and we calculate this red area equal to 0.45, and we can do like reverse engineer to calculate the k, because we know that when we look up the table, the z-score of 1.65 equal to 0.45. So we know that inside the z function, k minus 120 over 5 has equal to 1.65. And then after doing the algebra, we know that k is 128.25, and that is exactly the boundary. So that value means that if the patient is higher, if the blood pressure of the patient is higher than this value, that means the patient has blood pressure. If the blood pressure of the patient is lower than this value, that means we don't have like enough significance to conclude the solution, to reject our null hypothesis. So we'll stick with our null hypothesis. In our situation, our measurement for the patient is 135, and that is greater than 128. And that means we can draw the conclusion that the patient has a high blood pressure. On the graph, it means that since we are calculating the boundary as 128.5, so any area in between 128 and infinity is our rejection zone. So on the graph, this is like mu, and this is the 0.45 region, this is 0.05 region, and this value is 128.25. And our measurement is actually 135, which lies in the rejection zone. So we can reject that. So part C and part B are two ways of thinking of this problem. Part B is thinking about algebraically the p-value, and part C is thinking about like geometrically the distribution of rejection zone. And personally speaking, I would say part C is more like straightforward and provide better visualization. But you can use either way to conclude. And our conclusion is whether we should reject the null hypothesis or we should not reject the null hypothesis. Yeah. So with that being said, is there any question on this problem? If there's no problem, I will upload the quiz on B course. And just remember that the quiz, I will provide quiz correction. And if you are having big trouble on solving the problem, feel free to look at the discussion worksheet part 2, like on hypothesis testing 2. I actually list one of the problem there. Like that is very similar to the problem on the discussion worksheet. So if you go to B course files, you should be able to see the quiz. Okay, they're up on there. And the deadline is due 10/36. The quiz is due at 10:36. Yeah, yeah, actually, let me say something. Like for null hypothesis, like for this quiz, I want you to write explicitly your null hypothesis, your alternative hypothesis, and how do you like do the problem, do the algebra, and reasoning why you can reject or not reject the null hypothesis. You need to like do that. Um, yeah, and yeah, like maybe I will give you a hint on problem one. The hint is problem one is it might be like more tricky than what you are thinking about. So the problem one on the written problem. So that's like the hint for problem one. Remember, there's only 3 minutes left. Don't miss the deadline. Because I was just about to order a food from breakfast menu of McDonald's, and the deadline is 10:30, and I missed the deadline. So you guys don't miss the deadline for submission. There's 1 minute left. Just 1 minute left for submission. Okay, time's up. Okay, my screen is frozen again. Yeah, maybe let's do a lecture, a discussion attendance right now. Yeah, in the meantime, I would also like ask you to do the course evaluation. So like you should be able to receive an email indicating the course evaluation for Math 10B. And I mean, I'm just asking you to take this time, maybe like to do the course evaluation. And what I'm thinking now is that I decided to make a policy for quiz correction. If most of you, that means like at least 80% of you do the course evaluation, specifically the course evaluation on me. So there should be like a portion for JSI, and there should be just like few multiple choice on like the scoring. And if you like, if most of you has do the evaluation, I will allow you to do one quiz correction on any quiz. So you can choose your lowest quiz You can choose your lowest quiz and do a quiz correction. I will set up a Gradescope link for that specifically that quiz, that portion, and you can submit whatever quiz you want. And yeah, so you know your score for each of the quiz, so you can choose to submit a correction on any of the quiz. I mean, definitely do a correction on your lowest score will benefit you the most. That's something pretty obvious. Yeah, but also like, please do the course evaluation now. I need enough evaluation from you, and I hope like you guys can give me a good score on my evaluation. Because I don't even know how significant it is, but I believe that's definitely like a proof of my dedication in teaching. I mean, it would be great if you can give me a good score. I guess that's more like significant to professor, because that's like directly related to her performance in the teaching. But for JSI, I don't think there's any relationship between my thing, because like I get paid every month, and then the payment isn't changed with sort of like their evaluation. But I believe like on next semester there will be like a award for like the best JSI in the math department or something like that. Like there will be like 5 or 10 candidates for that, and I hope like if you can give me a pretty good score, I can do that. Your evaluation should be already sent it in your email address. So maybe like just search course evaluation. There will be like a portion or email sending to you, indicating like you should submit the evaluation for your different class. And within that, there's one class called Math 10B. And then you click in that, there will be like evaluation on professors, evaluation on JSI, and you can do that now. There are like pretty much only multiple choice. I mean, that's what the feedback I got from my first section. And also some of students asked me about their letter grade. And I'm not answering it right now in discussion. And also it's probably a private thing for you. So maybe like consider send me an email indicating your concern, whether you're like concerning if you're passing the class or not passing the class, or if you're concerning if you should do it PMP or letter grade. Like feel free to like send me all those emails, and I will give for each of you. I will look at your quiz, your homework, your test scores, and your own expectation of your letter grade. So we can like talk about that. Say if you want to stick with PMP or letter grade. And also some of students are asking me how do they submit the quiz correction and when. Like the way you submit is through a Gradescope. I will set up a Gradescope for like quiz correction, and you guys are all like submitting your quiz correction in that tab. But like within the tab on your first page, you need to write it very big. Which quiz correction are you doing? Like you should write quiz 5 or quiz 10. Like write it very big on the first page, so I know your quiz correction number. Yeah, and exactly when it's due, I still haven't figured out yet. I will probably make an announcement either today or tomorrow. Yeah, and also like the deadline will be sometime in the RR week. So at that time, I will also finish the grading for this quiz and next week's quiz. So you can choose like out of the 13 quizzes, which one do you want to do it as quiz correction? Yeah, and I believe I will. Yeah, I think I will get enough evaluation also from you. Yeah, and I hope they're good. I mean, if you are giving me a horrible evaluation, like just don't do that. Yeah, when I was talking about this in my first section, and they're like typing classical Z Hall in the chat. I don't know why I got this like stereotypical understanding from my students. But I mean, I feel like I explain a lot and actually spend a lot of time on giving you this good discussion. All right. I guess there's enough time for you to do the course evaluation. If you didn't finish, do it after class. And if you want to discuss with me anything, feel free to send me an email or drop in during my office hour. So let's talk about the poll. So the first question is true, because that's exactly what we do for the hypothesis testing. We assume the null hypothesis is true, and then we collect data, and we can do it either using the p-value or rejection zone to say that if we can reject our assumption on null hypothesis is true, or if we can't reject the assumption. So either way, we can get a conclusion. And for the second problem, it's a false. This is particularly important because we're not proving the hypothesis is correct. The verb proof is not correct. So in mathematics, we are using proof. We are using algebraic manipulations. We're doing a lot of things because like in mathematics, it's all about proof. But right now we are on statistics, and statistics is all about I'm presenting the data, and I'm presenting the data to persuade that you agree with my opinion. And in this case, actually, it's exactly what we're doing. We set up a critical value, the significant level, and this significant level is just a level saying that on this range, are we like confident enough, or like is that persuasive enough for me to draw conclusion that our null hypothesis is correct or our null hypothesis is incorrect, or should we reject null hypothesis or shouldn't we reject the null hypothesis? So that's important. We are persuading instead of proving. Okay, so I will end the pool. Yeah. So now I will skip second problem in section 1. The second problem is basically as same as the first problem, but instead of a one-sided test, it is a two-sided test. So you need to consider both left tail and right tails. But I guess if you understand problem 1, there's no problem for you to understand problem 2. Instead, let's look at problem 1 in section 2. And I will give you about 4 or 5 minutes on doing this problem. And then please update me with your progress on solving this problem. did you guys finish at least reading the problem? Maybe like we should do the problem together. So for section 2, problem 1, like for this problem, we're doing on a large samples. So remember for previously problem 1, this problem is only on one sample. We measure one patient's blood pressure and get the result. But now we are measuring a lot of people's results. And so for this problem, especially we call it Z-test, we're dealing with large samples. And so there are three differences between this and the previous one. First, we are doing Z-test in large samples. The second, we are using the sample statistics. So it's mu bar and sigma bar. And third, we're looking at proportions. But otherwise, the algebra is the same as the previous one. So maybe let's read the problem together. An informer claims that the miracle drug will cause you to grow hair at back. In a study, there are 25 participants and 7 people regrow their hair. If 10% of people normally regrow their hair without using any drugs, can you say that the miracle drug actually worked, giving the significance level 0.05? So we're giving the significance level alpha is 0.05, and we're giving that the true population mean, which is the proportion in this situation, is 0.1. 0.1%, like 10% of people who regrow their hair normally. And so we know that mu bar is equal to mu, which is 0.1. So also like the standard deviation, like since the standard deviation in this case is just because we are dealing with proportion, and proportion itself is just like a Bernoulli variable. So the standard deviation is PQ, where Q is 1 minus P. And this case is 0.1 times 0.9, which is 0.3. But remember, for the sample statistic, the sigma is equal to sigma, the population statistic divided by the square root of n. So in this case, we're dealing with 25 participants, so n is equal to 25. So the sample statistic is 0.3 over square root of 25, which is 0.06. So we're handling Z-test, large samples, we're calculating a sample statistic, and now we're looking at the proportions for the measurements. So for the measurements, there are 7 out of 25 who actually regrow their hair, which is roughly 0.28. That means 28% of the people who use the drug actually has effect on them, whereas the actually proportion, is 10%. So we want to say if 28% in this situation is actually significant. So the way we calculate that is to do a z-score, which is 0.28 minus 0.1, this is mu x bar, divided by 0.06, this is sigma bar, which is 3. And we know that the z-score is 3, so the p-value, so again, the graph is the same as the previous graph I wrote. This is z-score equal to 3. So the p-value is equal to the probability of half minus z3. So because like it is symmetric, so on this side, there's half of the values. And we know that z3 is 0, is the region here. So p-value in this case is just half minus the z of 3, which is about 0.0013. And we know that the p-value is less than alpha, which is 0.05 that is given. So that means the the calculation here we got is like significant enough for us to draw a conclusion that the drug has effect on that, which in this situation means that because like originally if you don't use any drug, there's only like 10% of people who actually has effect. But after using the drug, there are 28% people who has effect. So that means like the 28 is significant enough compared to the 10%. Yeah, that's why we can draw conclusion that we can reject our null hypothesis as there's only 10% of people. Instead, we are kicking our alternative hypothesis that the drug actually helps you grow hair. Let me know if you have any problem on problem 1. If not, we will look at problem 2. Okay, maybe we should look at problem 2 together. So for problem 2, I'm flipping a coin 100 times and get a total of 55 heads. I also think the coin is biased toward heads, where giving the significance level is 0.05. So first of all, we need to set up the experiment. We need to write null hypothesis and our alternative hypothesis. So in this case, our null hypothesis is that the coin is unbiased, meaning that the probability of flipping a head is 0.5. And our alternative hypothesis is that the coin is biased toward head, which means that P is greater than 0.5. So that's the setup for assumptions for the experiment. And then we need to calculate the specific statistics. So remember, this is just a Bernoulli variable, and each standard deviation, like each flip, is just a Bernoulli variable. So standard deviation is equal to PQ, where Q is equal to 1 minus P. In this case, this is just equal to 0.5. Yeah, because we're taking a square root. So the standard deviation of the sample would be the standard deviation divided by the square root of n. And in this case, it's 100 because we flip a coin 100 times. So the statistic is the sample standard deviation is 0.5 divided by 10, which is square root of 100. Is 0.05. And the samples, the measures we have done is that we have 55 heads over 100 heads. So it's about 55% of them are heads. So we want to say how is this proportion relative to the unbiased proportion 0.5. So we want to do a z-score on 0.055. Giving, so this is the x bar, this is the mu bar, and this is the sigma bar. And want to calculate the score, and we find that this so this 0.05 is just one standard deviation above the mean. So the z-score of one standard deviation is 0.3413. So if we look at the distribution, essentially we are finding that the p-value of, so this is z1, the value is in this area. So that's the p-value. In this case, is half minus the z-value of 1, which is this region here, which is 0.1587. And we know that 0.1587, this p-value is actually greater than our significant level alpha 0.05. Since like it is a lot greater than unbiased 0.5. It's actually a standard deviation above that. So we can, so because because the p-value is greater than alpha, that means we cannot reject. Actually I was thinking it wrong previously. So actually it's just one standard deviation above the mean. So that's not significant enough for us to draw a conclusion that this coin is biased. Because remember, like significance level alpha 0.05 actually corresponded to two SDs, roughly. So right now we only have one SD above the mean, so it's not significant enough. But for the previous problem 1, we're 3 standard deviation above the mean, and it's definitely higher than our threshold of 2 standard deviation. So in this case, we should reject the null hypothesis. But for problem 2, we should not reject hypothesis because it's 1 standard deviation above, and the p-value is strictly greater than alpha. So overall, like the problem of solving hypothesis testing, either it is one sample or large samples, are roughly the same. As long as you identify your correct null hypothesis and alternative hypothesis, and you understand how do you calculate the mean and SD, you're fine, and you know like how do you draw conclusions. Yes, so I think that's it for today's discussion. If you have time, look at problem 3, because for problem 3, instead of looking at continuous random variable, we're actually looking at discrete random variables. So in discrete random variable, we have like specific range of values. Yeah, and that might be different because we're not doing this course. And I believe there's enough there will be more practice on the homework. So you're officially dismissed, and I will stay here for 1 extra minute for answering any problems. Either that's a problem of today's class or this logistic problem in terms of quiz correction or your letter grading in this class. Like I will stay here for 1 minute or 2 minutes. If you don't have a question, just feel free to leave.
Yeah. Can you hear me?
Yeah.
I have a question about like our midterm 2. I was just going through our part 1, and I was wondering if there's like any like solutions page so I can see like what I did wrong. I know I can see like some of the answers, like the true or false stuff on WebWork, but then the ones that are multiple choice, I don't know which one would be the right answer.
Okay, so that's just for the non-written part, like non-written problem part.
Yes.
Yeah, I believe even for us, we don't have a solution for that because these questions are purely created by professor. But if you have specific questions, feel free to like ask me why it is wrong or correct. And those questions are actually pretty tricky. Yeah, we don't have an official like reasoning for each solution. We just have answers.
Okay.
Yeah.
In that case, if I have a good number of questions about them, should I like come during your office hours and ask?
Yeah, maybe do that. Or you can send me a email and then I will probably reply you in 24 hours.
Okay. All right.
Yeah,
Sounds good.
because sometimes the multiple choice question is a little bit tricky. I can't even say that why is this wrong. But actually, there's like a nuance between the phrasing between different problems. And if you change the phrasing a little bit, that's wrong. And if you change a little bit phrasing, that's correct.
Okay. Okay. All
Yeah.
right. In that case, I'll send you an email.
Yeah. Yeah. So yeah, I'm
Okay.
all right.
Okay. Thank you.